I'm extremely honored and pleased to have the opportunity to present here today. This presentation is going to go through CSX's journey to predictive maintenance and how we adjusted our long-term strategy in this whole process. So we'll start off. My name is Yousef Abdel-Moty. I'm currently the Director of Locomotive Engineering for CSX Transportation. Been with the company for 5 years and currently manage a fleet of 4,000 locomotives, developing lifecycle plans, specifications, modifications, anything related to improving reliability. For those of you that don't know, CSX is one of the largest railroads on the East Coast. 21,000 miles of track, 1,500 trains per day, 31,000 employees, allowing us to deliver 6.5 million carloads. So the way the presentation is broke up, we'll go through the long-term strategy, a lot of the corporate stuff, and then, which is exciting to me, is the second half of the presentation. We'll actually have the real use cases, and of course, I'll tie it to dollars. So it's something that's near and dear to my heart, right? So in 2004, CSX changed their strategy to focus on the profit drivers and the competitive advantages in the industry. And it really led us to asset utilization. As you can see, the financial results in 2012, 13, and 14, keep those graphs in mind. We showed an increase in revenue and profit because of this focus on asset utilization. And it was good that we did that because our infrastructure is aging. I mean, you look at some of our rail, it's got 1902 stamped on the side. It lasts for a long time, but it's starting to wear out. Technologies and innovation continue to expand, and the industry conditions, regulatory challenges with the EPA, and we continue growth and safety. All leads us to enterprise asset management. So what we did is we benchmarked internally and externally. We sent some of our executive team over to the largest conference in Berlin, the Intertrans. And what they brought back is they said, Europe is way ahead of us, guys. They've really got this enterprise asset management down packed, and we need to move in that direction. So we teamed up with a consulting firm called Argo, and we looked internally in CSX, and with the results, as you can see, are outstanding. It's really eye-opening. Our locomotives only spend 40% of the time pulling freight. We only make money when they're pulling freight, and that only happens 40% of the time. Our employees are productive 23% of the time. So this was extremely eye-opening. Hundreds of millions of dollars in avoided costs can be had from this. So we changed our purpose. We started focusing, improve asset utilization. So how do you do that? You focus on operating ratio and return on assets. And if you were a CEO of your company, maybe you are, one of the most important ways to do this and how you get your troops to rally around this is you tie it to compensation. So we have a long-term incentive program for executives, directors, and above, and it focuses on operating ratio and return on asset, and they're both weighted equally, okay? So, again, return on asset is your tax-adjusted income divided by your net property, and I'm pleased to say that we actually had a payout this year, so yay for us. And a lot of that had to do with those three charts that you saw at the beginning, the increase in 12, 13, and 14, because this program is based on a 3-year rolling average. So we compare stock price with how our return on assets are doing, and depending on how that goes, we get a payout or we don't get anything. So because of this new focus on ROA, we've developed new measures. API, or the Asset Performance Index, focuses on utilization, that concept of how much of the time is my asset making me money, and how much of the time is it just sitting around either intermediate at a terminal or out of service at a maintenance facility. We started to measure train delay index. What's the severity of a trip failure? How much does it cost us when we delay a train? Our track is single track. About 70% of our network is single track. So when we delay a train, we not only delay that train, we delay everything behind it. So $1 million train sitting on the track not only affects itself, it's got all the other $1 million trains behind it also. Impaired fleet and failures per locomotive year is how we measure our reliability of our assets. Our locomotives, are they out pulling freight, or are they sitting in a shop? So as we went through this exercise, we made sure that we didn't lose focus on the entire value stream. That local optimum doesn't do anything if our locomotives are completely optimized. We need to take into account our crews, terminals, cars, and track. And because of this, we lead into the second half, which is the predictive analytics. So at the core business, CSX is a transportation company. Simple, right? We move freight from point A to point B. We do it safely, we do it reliably, and we make sure to deliver our customers' goods on time. But we're plagued by this very famous PF curve. So we'll go through the curve with A being degradation, B operational failure, and C catastrophic failure. When we have C, the catastrophic failure, not only do we impact our communities, our employees, and our customers, but it's extremely costly. It's actually costed us $1 billion since 2003. We approximately have 2,500 derailments per year with a multitude of different cost codes. Now let me not concern you, not all of our derailments look like the ones in the previous picture. A derailment is just simply the wheel coming off the rail. But either way, it requires equipment to re-rail, and it's extremely costly. So because of this, we started our own IoT, and we've developed a network of interconnected sensors and wayside systems that continuously study the car movements throughout the East Coast. We call these super sites. So as a locomotive and the entire train passes through these super sites, it gets the acoustic signatures read on the bearings. It gets peak impacts on the rail, that pounding on the rail. I don't know if you've ever gone to the grocery store and got that one shopping cart that's got that flat wheel. Yeah, our locomotives do that too. And it's about 90,000 kips, so that rail's gonna snap. And the geometry and the AEI are looking at truck movement, the lateral forces, all the vibrations. And the AEI readers are positioning. They're counting the axles to let our train crew know if there is an issue, how far back should you go to find out where it is. We had a huge reduction in derailments, and this is what continued to bring about the predictive analytics. You can see from 2003 now to 2015, the cost impact just from impact wheel and bearing derailments is huge. So we focus on now part B, which is the operational failure. This is equipment failure. That's an extreme version of a flat wheel right there. That's actually the wheel is gone. The roller bearings burned off, and you have maintenance issues here on the wheel rail interface. The most important part is A. Let's catch the failure before it happens. Let's get really good at that time to failure portion. So we did some more benchmarking in 2014. Went to all these different companies, found out what they do and what we liked from it. And one stood out in particular, and the company's name is MTEL. And they're really, really big in the machine learning environment. And what really impacted us when we spoke with them is they didn't tell us what they could do. They told us what they were doing and some of the benefits and key takeaways that they've had, and they attached it to dollars, which is exactly what our E-team wanted. So we identified MTEL through their one of their customers in tech mining in British Columbia. A team of our directors went up and visualized the operation and spoke with tech mining and realized that there was $1.5 million in avoided costs that tech was experiencing by using MTEL. So this is what kind of got us to start a pilot with MTEL. So the big question was, can we predict locomotive engine failures using our oil sample and our repair and maintenance history? So let's talk about engine failures. We have 4,000 assets, locomotives, on our network that continuously are traveling through the eastern United States. They are not stationary. They travel through inclement weather, geography, terrain, tunnels. And we have about 40 engine failures per year, with each one costing over $100,000. And that's just on 2,000 of those locomotives. So it's easy to say that we have approximately 80 engine failures per year. So we said, MTEL, you guys are so good. we're going to give you some oil sample data. It's extremely time random every 21 days. 22 elements are measured from wear metals, copper, chromium, to parts per million in boron and sodium, to viscosity and total base number. So currently we use those samples and we only do simple threshold. If sodium is above X, then, set an alarm. But we don't look at them all together. There's no multivariate analysis that happens. So we started the pilot, and the pilot was in part in 3 phases. Find a failure. This was the MTEL prove yourself, right? You guys are so good. Here's some data. Tell me what you see. Then predict a failure, and then prevent a failure. So we'll go through the 3 phases. We focused on our GE DC Evo fleet, 472 locomotives. We gave them all of the most frequent oil sample 4. And MTEL randomly chose 9 and found 8 distinguishable patterns that were documented with failure. So we'll cover one example, CSX T901. This is what's called a probability wave. It's all 22 of those elements together in one graph, easy to visualize, easy to interpret. That red line is an anomaly that was stood out. And you got to remember, MTEL didn't know anything about oil sampling or our data. We gave them data and we said, tell us what you can see. So they created a virtual work order at that line, which is basically a way to say something happened here, let's flag that, and let's look before and after. And what they saw was increases in iron, viscosity, soot level, and anywhere. And they're able to tell us this through the software and how much percentage, I know it's kind of small there, each one has impacted to the signature. Little did they know that 901 was a bad actor. It was a repeater for low water pressure problems. Now, low water pressure is near and dear to my heart because our locomotives have a closed-loop system. We should not run out of water. And when we have repeaters like this, that water usually goes somewhere, and it usually goes into the crankcase and starts wiping out the bearings. So there's a summary on 901. We were able to find and train the agents against the failure, and we were able to correlate that with the actual maintenance history. And all this was, unbeknown to us that they were able to find such a trend. So they made a believer out of us, and we continued the pilot to phase 2, and we looked at our EMD ST70 fleet. About 235 locomotives and our most troublesome locomotives. This slide's missing a picture up top, so I'll speak through it. But what we did with those SD70s is our team identified failures, known failures for that locomotive group in the form of crankcase overpressure, engine component defective, engine running hot, and et cetera. So the idea was, let's build a model with these known failures. So for example, the 4553 and the 4548 each failed for crankcase overpressure. What we did is we marked that point in time and we looked back. And MTEL said, hey, I could have told you this 60 days before that failure happened. And we said, great, build a model. So we built that model and we applied it to our currently active locomotive fleet. And the 4778 was found during a transfer learning exercises. And what we found was pretty astonishing. We routed that locomotive to a maintenance facility. And granted, you can realize the challenges when I tell our power management, hey, this perfectly good locomotive, I need to take it out of service. This $3 million asset, I need you to route it to a shop. There was a lot of pushback. So we routed it. They agreed. We had to pull some strings. And once it got to Waycross, we told our team to perform a pressure test. What that is, we pressurize the cooling system to 20 pounds, and you check for leaks externally and internally to the engine. Waycross said, we can't find anything. There's nothing here. What are you guys in headquarters doing to us? So we said, perform a super pressure test. And what that is we actually blank the engine off, isolate the engine from the entire cooling system, and we apply 100 pounds of pressure to that engine. And what we found were 3 bad power assemblies. A power assembly is a piston rod assembly with the head, power packs that we just insert in. It's for quick changeouts, and we found 8 water jumpers leaking. So it's needless to say this was a good catch. That engine was leaking slowly into the crankcase. We were seeing the wear metals increase. And if we would have just stopped at that low water pressure test, it could have become catastrophic. So currently the pilot is extended to 600 locomotives. I'm pleased to say that just recently it's now up to 2,000 locomotives. We're still looking at our 24-hour of oil. Each day we give them a ton of data on oil, and they analyze it, they run it through the system. And we're changing the way that we do things. So you got to understand the railroad's been around forever. We, believe it or not, run everything to failure. We do maintenance on our locomotives, we do oil changes, filters, but on our major components, injectors, turbos, power assemblies, they run until they fail. We do not proactively change out components. And this is because why change it out if it's still working? Somebody a long time ago in finance said it's not worth it. The OEM is telling us an injector lasts 3 years, yet we're pulling out injectors that are 10 years old. So why do prescriptive preventative maintenance? This was the thought process. So as it's highlighted in blue there, prescriptive PIRs are new to CSX. So I hope you can feel in my voice the impact that these prescriptive PIRs are having. Here's an example of one for a fuel leak. So when MTEL identifies a locomotive, we apply this PIR, and it walks the craftsman through the steps needed to correctly perform and identify the fuel leak or water leak. This second example is just happened, and I threw it in the presentation because it's extremely important. CSXT 2004 was rebuilt 2 years ago. Had a brand new engine, brand new turbo, completely stripped down and rebuilt locomotive. Cost about $1.5 million to do that. It flagged in the MTEL system, you can see from the alerts in the email, for fuel, wear, crankcase overpressure, and fuel again. At first we thought, okay, this doesn't make any sense. Why is it flagging for all of these conditions? We sat down and we looked at the oil sample. We brought in our experts, and we sat down and took a look and found that there was something extremely odd about this oil sample. This was a signature that we hadn't seen in at least 35 years, which was how long our director of engines has been with the company. We routed that unit to the shop, and we found contamination, grit and sand in the crankcase. It was wearing away at the pistons, at the rings, at the main bearings. Brand new engine, 2 years old. And we were able to save a crankshaft, which is approximately $40,000, let alone what the crankshaft snapping would have caused blowing out the block and all the other power assemblies. You can see the excessive cam wears. That's a 2-year-old engine. That should be pristine. There should be no wear there. Oil bypassing the rings, coming out the stack and then falling back down onto the stack. So we were able to find these conditions, and it made us believers. And what's really interesting is those 22 variables were a blessing in disguise, because as we look at oil and we think about all the opportunities that this pilot has given us, when you start thinking about engine parameters, temperatures, pressures, vibration, that oil pilot really brought all those multivariate analysis together, and it was a blessing in disguise. So in the near term, we're hosting MTEL internally this year. It's in the works. We're replicating agents to the entire fleet, and we're integrating it with our Maximo, or asset management system, to automatically prescribe PIRs. We're creating a huge data lake with the Hadoop HANA environment, and so far it's running smoothly. Now in the long term, our current locomotive configuration, we have between 6 and 7 comm platforms on the locomotive that are continuously transmitting data, but they don't talk to one another. So in the future, we'll integrate all these comm systems off the locomotive in one nice package, bring it over to headquarters, we'll analyze it through the MTEL software, and we'll prescribe PIRs based on that. Now, each locomotive has about 300 data points, 300 sensors, and there's 4,000 of these locomotives running around all across the United States. So not only are we going to learn from each locomotive through class of power and through prescriptive analytics, it'll help us run a more reliable and smooth railroad. So to conclude, CSX has realized asset management is at the forefront. We have to do this to remain competitive. As you all know, coal is gone. We've lost about $1 billion in revenue in coal. We have to work smarter. and we have to work more efficient. We piloted with MTEL, and we were able to identify operational failures. And this last point I'm going to give, I think, is the most important that has really come out of this. We were able to do something in a large corporation that's extremely difficult to do, and that's change a culture. We changed a culture of not believing in predictive analytics. We changed a culture of craftsmen not believing in what we do to showing them facts and results and making believers out of them. So we continue in the Internet of Rail and predictive analytics, and we realize it's a key driver in our profit and losses. And with that being said, I am done. Thank you for your time. Appreciate it.